video series of our practical classes. My name is Dr. S.B. Sharafa, and I'm to demonstrate to you how to perform experiment 11 in our 100 level practicals, which is titled Vibration of a Fixed Spring. And the aim is to determine the mass per unit length of the wire of the sonometer. So to achieve this, we need a few items. We need a rubber bond, a tuning fork of known frequency, two knife edges to form a bridge, then we need a sonometer, and we need some weight that will give us the tension that we need in the wire. So how do we perform this? First of all, we separate the knife edges by 10 centimeters. So within that 10 centimeter, we have our separate L. We have our separate L. So our L initially is 10 centimeters. But we will not record this L because we are trying to find a resonance point. Until we get a resonance, so it's the L we have at that time that we are going to record at the, but we can always record the tension because we know the masses we have added to it. So we are starting with our 2 kilogram mass, which if multiplied by the acceleration due to gravity will give us 20 Newton. So that's where we start from. Then our initial length is 10 centimeters. So we try to see the point where this length will throw off the paper rider violently. So we try to see if the paper rider will fall off. If it falls off, then we have achieved our aim for this particular tension. So it's not falling. We increase this in step of 1 centimeter at a time. Then we try again to see where it's going to fall off. So it's not falling here too. We increase by another 1 centimeter. We repeat. So we have gotten this here because it has been thrown off up to that place. So what we need to do now is to measure this distance. Because there's a rule here, we need to know at what point it is. On this side it is 56, on the other side it is 44. So that means we are looking at 12 centimeters. So we record this because our table has been labeled meters, so we can't record 12 centimeters. This is 0.12 centimeters. And when we do same here, we will be having what? 0.014. Yes, I think so. So this is what we get for the first one. Then we are going to increase, now that we've achieved the first step, we'll increase this in step of 0.5 kilogram. So by adding this to this point, we started with 20 newtons. We are increasing this to 25 newtons because we now have 2.5 kilograms there. Then we try again to see where the paper rider will be thrown off again. So we reset to 10 centimeters, then we keep checking when it's going to be thrown off. So we need just the length of the wire in between this bridge. Okay, and this one end is on 57, the other end is on 43. So it's increasing. So this is what we'll do until we have about 6 more reading in steps of 0.5 kilogram each. So we'll assume for each of these we'll be having, if this one is still 1T2, we have T3, T4, T5, and T6. And we do same here, we have L2, L3, L4, L5, and L6. And we come here also, we have our L squared 2 up to L squared 6. So once we have this, our table is complete. Then we go into the analysis. This is the equation for what we have just done here. This is the frequency of the tuning fork. So remember, I said the tuning fork of known frequency. So we know this is known. What we have varied here is the length in between the bridge. So we have several of them, 6. For the tension, we have several of them too. So those are the 2 variables, while our mass per unit length is what we are looking for. So how do we get this? We first of all linearize the equation. Once we have the linear part, we see how we can rearrange the equation in such a way that we'll be able to get our mass per unit length. And the best form is this. L squared equals to T over 4 F squared. Where L is the length, T is the tension created by the addition of masses, M is the mass per unit length, while F squared, or F, is the known frequency of the tuning fork. So if we solve this, our slope, which is this, becomes becomes 1 over 4m F squared. This is what our slope becomes. This is what our slope becomes, equals to this. So if we rewrite that, our slope is equal to 1 over 4m F squared. What we are looking for, which is the mass per unit length, can be made the subject of formula here. Then we'll be having 1 over 4f squared multiplied by 1 over the slope. How is this graph going to look like? It's a straight line graph through the origin of this. If we plot L squared, a meter squared here, and we plot our tension, which is in Newton here, we should have a graph of this nature. So this is our slope, which is changing L squared here over changing tension here. So if we look at all these and we sum them together, we would have gotten what our mass per unit length is going to be after the substitution here. So what else do we need? We need to tell us the sources of error in performing this experiment. Remember, there are still other masses that you need to add. So once you have your manual, you should be able to follow through and complete the exercise. Thank you for listening.